Hello everyone. If we travel just 3 years back in time, coding still used to be a painful task. This changed when OpenAI launched its first version of ChatGPT, which was 3.5. It suddenly made programming and data analytics significantly easier for everyone. Since then, the tech community has not looked back. At present, we have tools like GitHub Pilot, Cursor, Code Whisperer, and so on. These tools can improve your coding productivity by 10x. There's another AI programmer that can integrate with your code base perfectly, and it's Windsurf. Let's explore Windsurf in this video and build some wonderful things in no time. So step one is that we are going to install Windsurf. So let me just type that on search. Download for Mac. I have a Mac system, so I'll go to this particular link. And I see that Windsurf is developed by Codelium. So for people who don't know about Codelium, Codelium is a very popular extension on VS Code to autocomplete code, right? And this is one of my favorite apps to autocomplete code on VS Code as well. So I'm quite pleasantly surprised to see that Windsurf has been developed by Codelium. So I'm going to download for Apple Silicon for my system, save it in the downloads folder, and just get through the standard processes of installing Windsurf. So the file is downloaded. We are going to hit the DMG file. Let's add it to our applications and let's launch it from the Launchpad. I'll give it the necessary permissions. Okay, let's go through the onboarding process of Windsurf. I'll click on Get Started. Now, this is interesting. Windsurf actually has been developed from a fork of VS Code. So the output would be quite familiar from what we see at VS Code. So I'm going to import the setup flow from VS Code so that I get a very similar feel to how I get on VS Code. So let me click on that. Okay, I'm going to import the settings and extensions that I already have on VS Code. This will make things easier for me. I prefer the dark theme. Okay, I would need to sign up so that I can also get some free credits. Let's do that. Open Windsurf. All right, I think we are almost set to go. Again, I'll give the necessary permissions. Okay, so now Windsurf is asking us to open a particular folder. Let's do that. I'll have most of my code files in a folder called code. So I'll open that particular folder. Yes, I trust the authors. Okay, so this is how Windsurf looks. The look and feel is very similar to VS Code, which is expected as it is a fork over VS Code. On the left-hand side, you see your folder structures. This is the space where your codes are going to be appearing. And finally, the magic of Windsurf lies in Cascade, this particular section, right? So this is the generative AI part of Windsurf, right? So Cascade is the agent that Windsurf uses to generate codes, right? So we have the option to ask Windsurf what we want to do over here. All right, so before we get started, let's look at some basic things. Let me zoom in. So over here, you would see that we have options of different LLMs that we would want to use. All these models, most of them require some credits, but don't worry, I think we get around 50 credits in the free trial, so we should be good to go. So we will be using 3.7 Sonnet. Notice that you can use DeepSeek V3 for free, right? So even after we run out of credits, we can use DeepSeek V3 for free, and DeepSeek R1 requires lesser number of credits. Okay, so that's about the different models which are available. There are two sections which are present over here. One is the write section, which can help us to generate code. And there's also a chat section, which can be used just like a ChatGPT, right? We can ask numerous kind of prompts over here. Let me go back to the write mode. And also let's look at our trial. Let's verify. Yes, we are on the trial and we get 50 prompts for the premium models and unlimited prompts for the normal models. All right, so when we use Cascade, it's going to recommend for us to install a lot of libraries, and that may mess up with our environments. So I would highly recommend that we install a separate virtual environment over here. And that's what I'm going to do. So I'm on Conda. I'll open the terminal over here using the control tilde shortcut, and then just type conda create. Let me call the environment Windsurf itself, or just Wind for shortcut. And then let's install Python version. Let me go ahead with the 3.11 version of Python. Okay, let's go through the process of installing this virtual environment. Okay, that's done. Let me close the terminal. Okay, now that we have our separate environment, Wind, what we are going to do is we are going to start writing a code. Once we create a test file, then we can change the terminal. So let me start with the very first prompt. I'll just say create a test.py file. Let's do that. Okay, it has created a basic file. Let me just accept it. And okay, over here we get the option to change the Python environment that we want to use. By default, it's using the Python which comes pre-installed with Mac, but I'm going to change it to the environment that we just set up called Wind. Okay, and it's asking to run the command. I think this is going to just print hello world. Let's just run it. All right, so there we see the output of the first file that we have created. Now that our system is set up, what we are going to do is we are going to try to create a game using Windsurf. Now on the internet nowadays, it's very popular to create a game of Snake, a game of Tetris using these AI pair programmers. But we are going to try something slightly more complex. Let's ask Windsurf to create a game of Pac-Man. Let's see how it does. So I'm going to open a new chat, which is always a good strategy if you're starting a new conversation with Cascade, just like you would do with ChatGPT. Let's type our prompt. Let me just zoom in a little bit. Create a Pac-Man game in Python. And let's hit enter. Okay, we get some prompts. I'll help you create the game using Python and the Pygame library. Notice that we have not installed any libraries in this environment yet. So it has just installed Python 3.11. So it would be asking us to install certain libraries over here, right? So it has done that. Let's accept. And it's going to take some time to install the relevant libraries, which we would need to run the code. Oh, it's modifying the existing test file that we created earlier. Not a great strategy. I think it should have created a different file, but nevertheless. Okay, so it has added all these different changes, right? So it has deleted the initial set of code about hello world, and it has suggested all these changes over here. Let's accept these changes and run the file. Let's see how the game looks like. Okay, this is the game which is playing. Okay, wow, that's quite good. So I see that the ghosts, oh, the game is over. Okay, so let me add a few changes over here. The mouth of the Pac-Man is not visible. All the ghosts are not moving at the same time. And add levels, it was too fast, right? So you observe that I'm adding prompts the way I would add it in ChatGPT. Let's see if it's able to improve the code based on this very general suggestions that we have given. It has understood the different tasks that we wanted to perform. It's going to take some time to modify the code. I also noticed that I think by default we are using 3.5 Sonnet. I think after this task, we will shift it to 3.7, the latest Claude version. Okay, so it has made some edits. Let's see how the game looks like now. It has not improved the face of the Pac-Man, but the visual feel is better. Now I can see multiple ghosts moving at the same time sometimes, but not all of them are moving at the same time. But you get the idea that through prompts, we can further improve this game, right? So some things for you to try is that you can ask the ghosts to appear in a particular format or a particular shape. Similarly, the Pac-Man itself, you can ask it to change it in a particular shape. But the code that you will be getting or the game interface that you would be getting would be slightly different from what I have got. So based on the improvements that you would need in the game, you can prompt accordingly. Okay, so with that, let us move to our next set of tasks. Okay, since at Analytics Vidhya, we focus on education related to data science, machine learning, and generative AI, we are going to try some tasks related to those aspects now. So let me start a new chat and let's change the model name to 3.7, the latest version of Claude. Now that we have changed our model to the latest one, what we are going to do is we are going to change some settings so that our code is always generated in Python. To do that, let's go to settings and we will go to we'll select settings over here and change the option of memory and rules. Let's go to manage and let's edit global rules, and a text editor would open up where you can specify the kind of rules you would want Cascade to follow. If you're familiar with the API interface of ChatGPT, you can think of it like a system prompt. So the first rule is unless specified, always generate code in Python. And second, I have a preference towards using the Python libraries Dash and Plotly for interactive visualization. So I'm going to make a rule for that. Always prefer to use Dash and Plotly for interactive visualization. Let's omit the part about the spelling and continue. Okay, so let's save these and come back to our Cascade chat. All right, so we wanted to execute some tasks related to data science and machine learning. So we will start with something which is kind of the hello world of data science and machine learning. That is the Titanic dataset. So we will ask our Cascade to create some code to generate EDA analysis, exploratory data analysis on the Titanic dataset. Let's see how it does. So I'm going to add a prompt, create an interactive visualization to do EDA on the Titanic dataset. I have mentioned interactive visualization. I haven't specified about Python. I haven't specified about Dash and Plotly in this prompt, but hopefully with this global rules, this should use those libraries. Let's see. Okay, I'll create an interactive visualization. Okay, no, it just analyzed the test.py file. It did not create. It's creating a separate file, thankfully this time. This is Titanic_EDA. And it did refer to some codes which are present in my coding folder, as well as the recent file that it created. Right, so basically, while it is getting created, one of the interesting things about Cascade, the agent, is that it looks at the various code files that you have present in your folder, right, to learn from them, to extract similar context, very much like a RAG system, although with a bit of difference. But we'll talk about it a little later. Meanwhile, our file is getting created. Okay, it's editing the requirements.txt file. Run command, yes. And there is an error. It did not find a module Dash. So it's going to install it. Let's accept that. So the good thing is it is indeed using Dash without specifying. The bad thing is it did not install it before coming out with the code. Okay, let's run the file again. Let's hope this works now. It is checking if the Dash application is initializing. Okay, there's a preview available for the file. Let me open it in the external browser instead. All right, this looks quite amazing. So we have a nice chart about the key columns. If you're familiar with the Titanic dataset, it is about the different people who were traveling on the unfortunate Titanic ship, the ship that sank. And it's a very famous data set in machine learning to analyze who survived and who did not. Right. So we by default see some charts over here which tell us about the survival rate based on gender, but I think we would be able to change it. So survival by gender, let's change it to something else, maybe survival by passenger class. Do we want to look at all the classes? Yeah, let's look at all the classes. we would want to look at all the genders. Let's apply a filter. Okay, so this is indeed a nice visualization app. It tells us the survival rate. So if you were traveling on passenger class 1, your survival rate was significantly higher at 63% versus if you were traveling at in the passenger class 3, that's 24.2%. And there are survival factors. Let's click on the passenger demographics as well. So indeed a very fancy app to analyze this data. And there are other options over here. We can also use age as a factor, right? So if you're children, and this is a good thing that if you were a child, you had a higher chance of surviving. And if you have watched the movie Titanic, you would have known that children and women were one of the first ones to get rescued on the lifeboats. So that's perhaps a valid reason. Okay, but coming to the point, had we started coding this output on our own, it would have easily taken us around half an hour to maybe 1 hour, right? But with Windsurf, this took us, 2 to 3 minutes to actually do this analysis, right? We didn't even download the data set. It downloaded the data set from a source, and it's a very popular data set, so it would have been not that difficult, but still, the visualizations it has created are really good. Okay, so with that, let's move to our next task. Okay, so we just did some EDA. I think now it's time to make it slightly difficult. Let's talk about gradient descent now. So this time, what we are going to do is, to start with, let's clear our screen. Let's start with a new chat. And this time, what we are wanting to do is we want to create an interactive visualization to explain the effect of learning rate on gradient descent convergence, right? So, gradient descent is generally shown in 2-3 different ways, sometimes in circles and sometimes in a U shape. So we have specified that we want to see the convergence in a U-shaped curve. Let's see how good is Windsurf on this task. It's again analyzing the test.py file that it had created earlier and didn't need to analyze any other files. It has already created a .py file. Hopefully it again uses dash because we have set it as a global rule. By the way, meanwhile, while it's creating all the files that it's creating, whether it is Titanic EDA or the requirement.txt file to install the different libraries, all of them can be accessed over here. And even, let's say, if you want to make some changes in the files it has created, feel free to do those. So the great thing is that you can get a very good set of code over here, and that can be modified to further improve it, right? Hopefully this test.py would be the Pac-Man file, yes. So all your files would be present over here. We have the gradient descent visualization, I think, ready to run as well. This is the code. Let's accept it. Yeah, it is indeed using dash and plotly. So that's the good thing that we set up in the global settings rather. Let's accept and see whether this one is working fine or not. Have the app working. The good thing is that before it sort of completes the code, it is giving us a detailed information about the app that it has created. It also checks whether the app is running before ending the conversation. So let's open this one again. And this is very nice again. So we get options to choose learning rates over here, and we get starting points over here as well. We can change the number of iterations as well. Let me try a starting point. Okay, let's change it to maybe 5. Iterations, let's keep it at 20. That's quite a lot. Let's choose all the learning rates, or maybe I'll try with too large of a learning rate. Okay, I think as of now, these buttons are not working. So I'm unable to select the divergent, the too large or too small option. Let me just run this if this is working at all. Okay, it's not working. It's looking quite good, but it's not working. There's nothing happening when I run simulation, or I'm not unable to change the learning rates. So let's give this feedback to Windsurf. I am unable to change learning rates, and nothing happens when I click on run simulation. Okay, so this is also something which is very important for us as programmers, right? So these apps would give us amazing starter code, but there would be some bugs like the one that we have just encountered. And it's a good strategy to look at the output and give a prompt on the modifications that you would need in the code. Okay, so let's wait for Cascade to come out with an improved version. Let's accept the changes that it has come out with. Okay, this was basically just wanted to kill the existing version which was running, and now we can run the version. Let's open in the browser. Am I able to run the simulation? Not yet, I guess. Yep, this is a bug that it's not working well, so probably we would need to prompt it again. Let me just check if other things are working. Zooming in is working in this path. Right, so some options are working and some options are not working. Let's go back to home, reset access. So there are many buttons which are still not working, but I think you get the idea, right? We would need to probably tell it that some of the options are still not working. And let's just maybe quickly try to fix it. Okay, let me just try one more time. Still not working. And this is the final time that we will try with this prompt. If it does not work, we'll move on to a next task. But sometimes we will need to prompt again and again. The other approach is that we go through this code and try to fix it on our own, which is also not a bad idea, right? Because we have already got a very good starter code and we can walk through it and identify the bug. Okay, so it is taking a different approach now. It's trying to create a simpler version, which is more likely to work reliably. Makes sense as a strategy. Okay, let's kill the existing version. Yep, that's killed. Let's run the new version. It's open in the browser. And let's, yep, again, the buttons are still not working. Yep, so never mind. Yeah, sometimes we would need to prompt again and again and for it to come out with the revised one. So the starting points are working. So if we change the starting points, our graph is changing. So these buttons are working. The number of iterations, let's see. Yeah, the number of iterations is also working. The one which is not working is that if we don't want to use all the learning rates, if we just want to see one of the learning rates. So currently it has drawn charts for all the different learning rates, 0.01, 0.1, 0.51. So we do get to see the information that we really wanted to. But since this button option over there, I would want it to work as well. However, yeah, we do get to see the effect of different learning rates and whether they're converging or not. So in the interest of time, let's move on. Now, before we go to our final task, let me show you some other things in the Cascade interface. So number one, if you want to look at any of your past conversations, they are visible over here as well. You can also click on this icon and yeah, they're already available over here. So we needn't click on that icon, but yeah, you can see the different conversations we have done with Cascade right now. Okay, so that's one. Second, we were discussing about how Cascade accesses the files that we have in our folder, right? So we can use it to our advantage as well. So let's say I'll show you a file that maybe I have. I think there was a file that we tested on to create a learner query resolution agent for analytics with there, right? So I have a smaller version of that file in my system somewhere. Let me find it out. I think there are various things that we tried over here. Maybe I'll give an incomplete prompt to Cascade, right? So this is this file RAG system for query resolution, right? So I'll just say analyze the file RAG system for query rather than giving the entire file name. Let's see if it works. Okay, so it's looking for the file, if it's there or not. And indeed, it has found the file. It is IPython notebook, and it's giving an analysis. Oh, very nice. So it's telling us that what we did in this file was we created a vector database store, then created a query processing pipeline. Very interesting, right? So Basically, we can chat with the different files that we have in our folder. We can ask them to modify it. And if we have a lot of rich amount of files which are present in a folder, it's going to also give better results. So if there's a particular kind of code that we do, then it would have reference to some of these files and would probably create better replies for us in those kind of scenarios. So I don't actually create a lot of games, so I would not have any code files related to games. And similarly, with a lot of interactive visualization, I would still have some codes related to RAG pipelines and agents, which would give it a better idea about how to generate those kind of codes. There is a little bit of privacy concern over there as well on whether our proprietary code is getting used by the system. Hopefully, they have taken care of the privacy issues. If not in the trial version, I hope they have taken care of that in the paid version. Another interesting aspect that the Cascade agent brings in is the way it retrieves the information from the code files. Right? So unlike traditional RAG systems, which work on embeddings, and embeddings are used in RAG systems to make the process more computationally efficient. But they also add a little bit of abstraction and lossiness to the entire operations. What Cascade Agent does is it does not look at embeddings. It looks at all the pieces of code in your code base and looks at their similarity with your query through an LLM. Without first converting the query and the code base to embeddings, it looks at specific sections and does try to do an exact match. And I read a small review by Windsurf that the accuracy that they get with this approach is significantly higher versus if they use embeddings, right? So that's something very interesting about Windsurf. And what this would mean is that we will get better context for generating code as well. Okay, so with that, let's move to our last and final task. Maybe let's start with a new chat. And since we were talking about creating RAG pipelines, let us try to create a RAG architecture. So let's say we want to create, I already have this prompt listed, so I'm just going to copy paste it. So what we are doing is we are going to create a visual RAG application using LangChain, CrewAI, and ChromaDB to query uploaded financial statements like annual reports. And let's see how Cascade works on this. And I would also be interested to see if it looks at some files which are present in this folder, which can give it more information. So it does look at code. Okay, interesting. And now it wants to install some new libraries, which makes sense. I don't think it has used LangChain or CrewAI earlier in any of the codes that we have worked on. Makes sense. It may take some time for us to actually install these libraries as well. It has created a document processor. And again, we have asked it to create a visual RAG application. Hopefully this time it works. Last time we had a bit of a bug. It has created a vector store. It has created an environmental variable as well. I think we would need to add a key over there. While it is going on, I'm sure it's going to ask me for OpenAI or some key. So let me fetch it till then. Okay, so it has created several files. It has created a .env file, a document processor, .py file, vector store, agents, hopefully using CrewAI, and now it's working on creating a Dash application. Still not installed the libraries yet. I think it's going to ask us to do that. Okay, so lots of work which was done over here. Let's say keep all. It has created a separate folder called financial RAG and lots of files over there, but I did not notice it installing anything. So I'm going to run all, but hopefully, or I think we may hit an error while we run this file. It's going to take some time to run this file. Okay, it says open your browser and navigate to this. I forgot to read that. So let's go to the browser and not working. So let me just type in, it's not working. And this time, while it's trying to rework on the code, let's have a look at some of the code files. Right, so this is the app.py file. Largely, it has the Dash components. let's look at the documents store. Okay, it's using LangChain over here. It's using text splitter for chunking. It's realizing what kind of document do we upload. Okay, this is very interesting, right? So even though this code would not work, I would really be happy using this code to modify it for my process, right? So it's understanding whether a document is of docx, pptx, csv, because I don't think we specified it in our prompt. So based on that, it's going to do appropriate processing. There are different libraries which can help us break the text depending on the file type. Okay, and this is the document processor. Let's look at the vector store. Is it using ChromaDB? Oh yes, it is using ChromaDB, and it is using ChromaDB from LangChain itself, right? So LangChain itself also has Chroma, and it has installed ChromaDB separately as well. But I'm guessing it's using the Chroma version. All right, so it has the code for embeddings. It has created functions to do similarity search with score as well. So really happy with the kind of code which is created. Even though it would not run, I would be happy to start with this code and create a working model of this task. I would probably want to use OpenAI embeddings. I think it is using Hugging Face embeddings, but yeah, that's one change that I would definitely would want to do. Okay, yes, it is using an open source embedding, sentence transformer. Yeah, I would want to change it to OpenAI in my final version. But for this version, let's just accept the changes. It has not found certain module, and it's going to edit it. I think for this particular function to actually work, it's going to require quite a bit of uh, back and forth, right? So it is asking me now to install certain libraries, which I would say yes to. But the key idea over here is I'm quite happy with the first version of the code that I have received for this complex task, right? So this last task was fairly complex. We wanted to create a RAG system which can take financial documents and then we can query it, right? So with just this boilerplate of code, it has definitely saved a few hours for me. So I'm still quite happy, even though we are not getting probably a working version. It's still asking me to install some more libraries. I won't read which files it wants me to install. I'll just say yes. I think now it's installing some of the key libraries. There's a version conflict between LangChain and CrewAI. So I do know that CrewAI is built on top of LangChain, but maybe it has installed some versions which are not compatible. It's updating the requirements. So that's good that it's now finally installing the key libraries that we had asked it to. I'm going to continue with this in my own time. As we discussed, this process is going to take some time, but quite a good piece of code to get started with. And this concludes the hands-on part for Windsurf. What you just observed is the future of coding. From analyzing data to building apps, these technical tasks are now accessible to everyone with a functional laptop and internet. The only skill you need is curiosity and the ability to ask the right questions through prompts. I would also say that it's still beneficial if you have some programming skills so that you can evaluate and improve the final output either on your own or through an AI programmer like Windsurf. What you just observed in this video is also being termed as vibe coding these days. That's it for this video. Let us know what you used your favorite AI programmer for in the comment sections below.